Okay, Assalamualaikum and good morning. Can somebody answer me whether you can hear me or not?
Salam. Can, Doctor?
Doktor can hear.
Hello? Okay, can somebody try again?
Can, Doktor.
Okay,
Can,
good, good.
Doctor?
Okay, so today we will continue our study with chapter 6. Okay, so chapter 6 will cover input and output. From previous class, we actually already done some of it. So maybe this topic is quite easy because we already look at it. Okay, so our objective today is to learn about input and output. Okay, so input here is the input coding. Okay, and then you have you already also see the display function, fprintf and sprintf. So all of these are inside Matlab, inside. Okay, so input and output inside Matlab. So there is also input and output other than Matlab. So for this one, you use a it's called ASCII or binary file. This one is .mat. So this one is not usually but if you use Matlab, usually we use this one. You can also import and export from Excel. Okay, so this is outside the Matlab. Okay, and also we will learn about debugging. Okay, so basically there are 3 parts in the topic today. Okay, so just to recap, okay, so you have program, you learn about the variable operation, function and everything. So that is a program. So of course a program needs input and output. So today we focus on this one and this one. Okay, so prompt data. Okay, so create at the command window. So when you create a data at the command window, you will create a prompt data. Okay, but the problem with this data, okay, you write something inside the Matlab, is when you clear it, okay, you use a clear function, you write clear and it will gone. Or if you close Matlab, it will gone. So in order to save all the data you have created, you can use import and export. So you can import or export in terms of .mat. This one is basically the Matlab file for data. Okay, or text, you can also save as JPEGs, okay, MP4. Okay, so this is a permanent data. So this one, if you turn off Matlab, it still exists. So we move on to the input. So in the previous chapter, you learn about this input. So if you have any message, you put here. Okay, you put prompt. Okay, but if the input is number, you can use this. Okay, directly. So, but if the input is string, means that ABC, so you have to put comma and this one, just to indicate this is a string or characteristic. So let us see here. Okay, example 6.1. So you have height and width. So how to calculate the area? So width width multiplied by height divided by 2. So you will get something like this. So if I open Matlab, okay, create a new script. Okay, like I said before, if you don't want any data to save inside here, you can write clear. So basically, it will clear all the data. Okay. So if you run this, okay, of course you have to save first. Okay, enter height. Okay, this one 10. Enter width. So 20. Okay, you get the answer. So basically, if you have input, you have to save it inside a variable here, height and width. And don't forget, if you want to create a prompt, you just put here. Don't forget this, open bracket. Okay, and usually if you want some space, make sure you add some space. If not, it will be close together. Okay, this is for input. And after you get the input, you can process. Okay, this is the process. So basically, the input here, you will use inside this equation. Okay. Oh, there is no string, right? Wait. How about if you want to insert a string? So for example here, maybe, okay, if you want to insert string, okay, this one doesn't care. Okay, so, right. So if you want to insert ABC, so basically just put S. Same here, put comma, open bracket S. Okay, so if you run this, okay, for example, you write AAA, BBB. So this one is basically try to print out again. So you can see that height is AAA, width is BBB. But if you don't put the S, okay, for example here, okay, if you don't put the S, you run this, okay, you can see here, for example, I put AAA, okay, it will be error. So that's why if you have characteristic ABC, okay, you have to put comma, open bracket, S, this one, okay. So that's it for input. Okay, now we move on to the next part, which is output display. So there are 4 types of method you can use to display output. Okay, the first one is basically you just create a function without semicolon. I think this one I already show you many times. Okay, so let's say I give you A equals to 100. Okay. Okay. So if you look here, I put semicolon. If I run this, okay, CLC. Okay, if you want to clear this, you put CLC. Okay. Clear common window. So I run again. Okay. Okay. See here, A is equal 100, but it will not show in the common window. So basically, if you remove the semicolon, you can display the output. See, you get A is equals to 100. Okay, that is one method to display output by removing the semicolon. Okay, without a semicolon. Okay, next, if you can see here, if you don't want, okay, if you see here, the output is A equals to 100, and you don't want A equals to. Okay, you don't like the A is equals to. So how to do this? You just put this, you put this P. Okay, display. So open A. Okay, if you run this, it's only producing the value. The name of variable is ignore. Okay. So this is both. Okay. So another way is fprintf and sprintf. So I will move on to the next part. Okay. Okay, this one is for display. I already told you how to show it. Okay, basically, if you put X, something like this, okay, because you have semicolon, it will not show. And then if you put without semicolon here, it will display. Okay, and if you use display function here, it will not show X. Okay, X equals to will not show. This one will not show. So depend on you which output coding you want to use. Okay, next we move on to this one a little bit tricky. It is called a file fprintf. If not mistaken, it is a file print format. Okay, it is It is usually used if you want more control of the output. If you other than display. Okay, display you cannot control. You just display it. But fprintf you can control the decimal point, what is the format of the writing and everything. Okay, if you have a vector or array you want to display easily, you use fprintf. Okay, so the coding is basically this: fprintf. Okay, and open bracket. Okay, and then you have the prompt, and then you have the variable. Okay, this one also, okay, this one is quite difficult to understand. I will show you example. It's much more easy to understand. So, okay, you can see here. Okay, usually we start with the percentage. Okay, and this one is the conversion. So what format you want to use? You can use either D. D is basically decimal. Not decimal, integer. So 1, 2, 3, 4, 5, 6. Okay, this one is good for example, people. So you cannot say that there are 1.2 people or 2.2 people. So you have to use a decimal. Okay, or you have to use you have to use integer. Use this. And this means that it has positive and negative. But if you don't want negative sign, you use U, %U. Okay. So if you use floating, okay, F, okay, basically is fixed number. Okay. So string is, you know, what is string is the ABC, and E is the usually for scientific. For example, 20 multiplied by 10 negative 6. So this one you use this. Okay, if you have you involve number that is micro or milli or very large, I suggest you use exponential notation. So how to use this percentage and the conversion? Okay, for example, you can see here you have cow is equals to 5. Okay, so you see here semicolon means that it will not print. Okay, and then you want to have a text, so you write fprintf, and then don't forget the open bracket and close bracket. Okay, there is a, okay, you want this data inside this place, so that's why you use percentage and f. So basically it's what you call a placeholder. Okay, placeholder for the number, and after you complete this, you put the variable after this. Okay, for example, you have variable here. Okay, you put here, automatically it will go inside here. Okay, that's why you place % and 1.2 f. So for this case, you use a floating. So floating means that okay, the fixed decimal point. Okay, so let me show you in the Matlab. Okay, I remove this first. I will show you what is this mean. Okay, so you can see here there is it will insert the value inside here. Okay, the cow is equals to 5. So it will put this value and it will show like this. Okay, so that is how the percentage f work, and you have to put the variable at the side. Okay, so you see here there are 5.0000. You don't want that because there is no 5.5. cow or something like that. So remember that I said you can use integer. See here, you can %d or I, or you can %u. Okay, you don't want this format, so you can change this into d. D. Okay, for integer. So if I run this, there are 5 cows. Okay, so that is how you can change the type. Okay, if you, for example, if you want exponential, okay, so it will have e. Okay, exponential plus this one. Okay, so this one is basically, okay, exponential. Wait, So what you mean by okay? So for example, you have 5 multiplied by 10 negative 3, for example. In the exponential form, it will show as 5e negative 3. So there is no superscript. There is no superscript inside the Matlab. So it will show as 5e negative 3. Okay, that is how you choose the type. Okay. How about the string? So S. So cows is, don't forget this one, FIVE. Okay. So if I run this, okay, it will show as string. Okay, ABC. Okay. So this is how you manipulate it. So change back to 5. So you already learned how to use this type. So this one, make sure you remember, this one will not be given. Okay. The format is not given. So you have to understand S is for string, exponential, floating. This one is integer. Okay, there is another one, is %g. Okay, basically Matlab will guess it for you. Okay, so this one is not in the syllabus actually. So you can use it, but I don't recommend it because this is the only format. Okay, in only course the format included in this syllabus. Okay, now you can see here, what is this number? Okay, what is this number? So this one is basically, okay, okay, if you look here, so if you look here, this one is basically the decimal point. So when you run this, you can see here, this is 2 decimal point. So how to use it? You just put dot this one. Okay. And how about this number? Okay, this number represent the location reserve. Okay. So 1 digit before the decimal point. Okay, this one is hard to understand. So just this one is basically how many place for the cow, for the number. Okay. For example, if reserve is 1, means that it reserve 1 number. Okay. For example, you reserve 3 number, it will reserve 3 place. Okay, 3. Okay, don't forget the dot. Okay, I'm not sure whether dot is count or not. Let me check after this. Okay, and for example, if 5, okay, it will reserve 1, 2, 3, 4, 5. So let us see the effect. So I give you %f. Okay, if you run this, it has many decimal point. So how to reduce the decimal point? You put two dot between the percentage and f. For example, you want to be 3 decimal point. So percent dot 3. So if you run this, it will have 3 decimal point. Okay. If you have 4, you run this, it will have 4 decimal point. Okay, how about the number before it? So this one is just a placeholder. For example, here I put 3. Okay, means that okay, I run this. It will reserve 1, 2. Wait, 5. Okay, it will reserve 4 location. So you can see here 4, 1, 2, 3, 4. So because this is 4 number, so it doesn't affect. How about 5? Okay, if you see here, you check here, focus here, it will reserve 1 location. Okay. Okay, maybe for 10, it will reserve 10 location. This one 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10. So basically it's just reserve. Okay, this is very good if you have multiple number. Okay, for example here 5 and 5, 6, 7, 8, 100. Okay, something like this. Okay, if you run this, okay. Okay, when you run this, you can see here it will continuous. So how to goes into the next line? So basically at the end here, you use a backslash. Okay, this one. Okay, at the top of the enter and end means that new line. Okay. So you can see here that is the function of this placeholder. It's basically give a space so that your printout will be the same. Okay. So the same length. That is why this one is important. Okay, if for example you only use 4, but there are number larger than that, okay, it will become something like this. It will be skewed. So this is why this is important. Okay, so what's next? Okay, if for this case you have fprintf with multiple value. This is the next part. Okay, previous example, okay, I give you only one value inside the variable. But what happens if you have multiple? Okay, let us see the example here. Okay, if you run this, okay, I delete this first. So if you run this, L is this one, okay. So automatically it will print with the exponential form, okay. So if you, easier for you to see here, it's basically something like this. Okay, you have 20,000, 3.33, 3,300. Okay. So this one is only one variable. Okay, this one is one variable. So this one is only one variable. But you can see here there are 2%. Okay, 1 and 2. Okay, easy for me, just give a space. Okay, so you can see this is a floating number. Okay, this one is decimal number. Okay, so floating decimal. Okay, this one 5 means that it will reserve 5 location of the number, and this one 2 location with 2 decimal point. Okay, so if I run this back, you can see that 20. Okay, 20 is maybe this one. Okay. So automatically, this one will take one value. Okay. This one will take one value. But if there is more value, it will run again fprintf. So what it means that you can see here, 20, this one. Okay. Remember that Matlab will read from the top first and then complete the reading in the first column. Then after complete the first column, it will go to the second column. Okay, so it will go down first. Okay, if you have multiple data, it will go down. Okay, and then it will, after finish the first column, it will go another round, second column. So that is why for this one, it will take this value, and then for this one, okay, it will take the second value, then it's finished. But there is more data here, this one. So it will take run again the fprintf. It will take the first one again, the second one, and then this one will go here. That's why it will become like this. Okay, example, I give you another example here. Okay, 40. Okay. So if you want to print this one you have to change. So this one is 3.3, and then go to the top here. Okay, you have to change it 3300. This one is 4.4. This one is 4400. So remember, it will read this first, and then this one first, this one. Okay, if you run this, then it will go something like this. And you can see it's crooked, right? So in order to fix this, I place this 4 location, because 1, 2, 3, 4, 5. So 5. So it will be same location. Okay. And if you don't like something like this, it's hard to understand, right? So another way is you just put a long list. Okay. For example, here 20,000, 3.3, 3300, 4.4, 4400. So it is just a long line. So if you run this, so it will produce the same output. So because it's only one row, it will just go this way. Okay, if not, it will go down first and then we go next. Okay, that is how to manipulate the multiple value. Okay, this is a special character that you cannot use. Okay, inside the prompt. Okay, so this one quotation mark, you cannot use this. Okay, for example, it's something like this. And then you put inside here something like this. You cannot do this because this is already reserved for Matlab. Inside the prompt, you cannot put a quotation mark. Okay, so make sure in the prompt you don't use quotation mark. Okay, and then percentage, you also cannot use this. Okay, this is reserved for new chapter. Backslash also cannot. Okay, backslash line n is the new line. Backslash a is the alarm. Okay, you also cannot use it inside the prompt. Okay, also this one and this one. Okay, so you cannot use all of this inside the fprintf. Okay, you can see the full list in the Matlab documentation. Okay, now we move on to the special, Greek letter. Okay, alpha, beta, omega, pi, that one. Okay, you can print a Greek letter here actually. So how to print it? So you can see here, this is the Unicode. Okay, this one I'm not sure whether you have to memorize this or not, but I think you don't have because it's too much. So you can, for example, if you want to use pi, you have to know the code. The code is 3CO. Okay, pi is 3C. Pi is 3C0. Micro mu is 3BC. Okay, omega is 3C9. Okay, something like this. So you have to memorize the hexadecimal. So I'm not sure whether you have to memorize it or not. Okay, but if you want to use it, you can refer to the Unicode hexadecimal. Okay. So how to use it is basically you just backslash. Remember backslash, not slash. Okay, slash is near the shift button. Okay, backslash is the top of the enter button. Okay, and you put X, hexadecimal is X, and then the code. Something like this. Okay. So, for example here, W is 0, pi over 2 or 90 degree. This one is 180 degree pi. This one is 230 degree. So this is W, omega. S is the sine W. So basically you multiply all of this number. And omega, okay, you assign as this. So basically you want to print this f print f omega. So basically it will call this back, okay? And then don't forget the open bracket, sine, okay? Open bracket omega, close bracket is basically you call back this number, okay? Close bracket. So because this is just what you call the header, it doesn't have any value, okay? It doesn't have any variable. So there is no comma, okay? There is no comma here. And then after that, you print all the value. So you can see here, f print f, this one is floating number, and then this one is also floating number, and reserve 10 location with 3 decimal point. So this one location, 1 decimal point. Okay. So to call this, okay, it will create a table here, something like this, and this. Okay, it will create W divided by Pi. So basically this one divided by pi. Okay. So this one divided by pi is basically becomes radian. Okay. And then this one is the result. This one. Okay. So let us run this. So okay, I run this. Okay, right now it is in the third row. It will create W. You can see here W will be created here. And then it will calculate the S sign value. Okay. And then run, it will make sure that the character dash x3c9 is omega. Okay, and then you can print it. Here I run this, it will print this. Okay. So you can see something like this. So you can see it's not correct. Okay, you can see here it's not correct. Okay, why? Because you don't put the new line. Okay, and you have to put the semicolon to remove this. So I put the semicolon here. And then here, don't forget the backslash n. So it will create a new line. So I run this again, it will follow. Okay. So for example, if you want to reduce this distance, you just put this maybe 8. So it will reduce the distance. Okay, that is how you manipulate this. So this one is basically, for example here, I don't want to use this. I just want to use a table. So you put here this one. Okay, and then you can use table. Okay, or any variable table, for example, 1 1. Okay, 1 1 1 1. Okay, it also produces same result. So if you look the table here, table 11, you can see that it will follow something like this. This one, and then this one, this one, this one. Okay, it will print this one, something like this. Okay, remember the direction of the number. Okay, and inside here also you can call the omega. So you can see here omega is dash backdash this one. Okay, so it will produce the pi. Okay, or you want to give a space here. Okay, so basically you can call the hexadecimal inside here, inside the prompt. Okay, the message. Okay, for example, if you want to change the pi into, for example, degree. So if you want to change it to degree, just check this one, the hexadecimal, which is B0, and then leave the X, just write B0. So if you run this, it will change to degree. Okay, that is how to use the Greek code. Okay, Greek letter inside the fprintf. Okay, we take a break and we continue with the sprintf function after 5 minutes. Okay, don't forget to check in your attendance. Okay, just a reminder, for this week, you have to finish quiz 1. Okay, it will be 5% mark, and it will cover chapter 1 until 3. And also, just a reminder, you also have test 1 at 30th April. Okay, at 13th April, you have test 1. It will cover chapter 1 until 5. Okay, until the function. Okay, we continue the lecture with the sprint f. Okay, I forget what is the S mean, but this one is print format. So basically, sprintf and fprintf is same function. Okay, but the advantage of sprintf is that you can return the display of the variable. Okay, basically you can save the print. Okay, for fprintf you cannot save what you have print, but for sprintf you can save it. Okay, for example, creating a sequence file name when there are a number of files to be created at once. Okay, dynamic cell range. Okay, graph annotation. Okay, this one is the advantage of sprintf. Okay, this is the different. Okay, you can see here. If I save the printf value, okay, inside the f, basically it will display number. So what is number mean is just this one. 1, 2, 3, 4, 5, 6, something like this. And then 4 until here. And then don't forget the 4 is the 4 location. 1, 2, 3, 4. And then this one this one. Okay, basically it's just print the number of character. Okay, so it will save as this one because there are 24 character here. It will place the number of character inside a 1 multiplied by 1 array. Okay, so if you use fprintf, it's just that. But if you use sprintf, basically what you print here, it can be saved. Okay, example, it will save is in s. Okay, all this, okay, all this value will be saved here because this contain 24 character. It will save here. Okay, so instead of a double, means that the number, this one is number, it will save as character. So this is the difference between sprintf and fprintf. You can return the variable. Okay, I'm not sure whether you want to do this or not, but okay, I give you example here. Okay, okay. So if you look here, okay, of course, remember, if something like this, you have to rewrite again. Okay, so this one also repair it. Okay, I save it. So what's starting value you will like? Okay, 0 degree. Okay, and what is the final value? Maybe 180 degree. Okay, what the increment? Maybe 20. Okay, so basically it will save all the input here, input 1, input 2, input 3, and we will create a, okay, the step. Okay, remember, a starting value, okay, increment, final value, and then you have to change it to radian. Okay, okay, change the value into radian, just basically divide by 180. Okay, multiply by pi, of course, but for this case you cannot multiply by pi. Okay, it's easier for you to read. Okay, because you will put pi here. Okay, just divide by 180. And then you create a table. So basically, you create a table, you print out the degree first. Okay, you print out the degree and then you print out the radian. Okay, for example, here you want to see here. This is the result. So basically, it will print side by side. Okay. This one, remember this? This one means that new line. So it will print the degree first. Okay, if you look at the degree, it will be long. Okay, if you look at the radian, okay, this is the degree and then this is the radian. So basically, it will transfer this into the second row, something like this. Okay. So after complete that, okay, this one display a table of radian. This one is just a display code. Okay, it will not produce anything. Okay, and then fprintf. This one is the header. Of course, this one you can see here. This code is basically for the first one. No, the second one here. So degree, you have degree and then this one. Okay, the hexadecimal code. And then same one, okay, pi. Okay, remember this 3CO is pi. And then radian. Okay, and this one is the new line. And then next, you print all the value inside the table. So remember in the table, it will print this one, this one, this one, this one. It will print something like this. Okay. So you can see here, this is the placeholder. Okay, 6 place. Okay. So 1, 2, 3, 4, 5, 6. So it will reserve 6 place. And then 2 decimal point. Okay. This is a floating number. And then for this case, it will hold 10 location. So of course 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course you have space here. It will also go here. Okay, this is the degree. Okay. The XBO is basically the degree. Okay, this one is new line. Make sure you put the new line. If not, if you don't put the new line, it will be long. Okay, if I run this, okay, it will be long. There is no new line. So you have to put the new line. Okay, if I run this again, 0, 100, 20, okay, it will be new line. Okay. Okay, that is the example of using input display and fprintf. Now we move on to import and export data. As I mentioned before, the input display fprintf is basically just inside the Matlab. Okay, if you close it, it will gone. So in order to save this value, okay, the data, the variable, okay, I suggest you use import and export. Okay, in this class, I will show you two methods. Either you save it in the .mat or Excel. Okay, Excel, the Microsoft Excel. Okay, you can use both. Okay, I move on to the first part. Okay, so okay, the import and export. So basically import, of course, from this, okay, from your computer to your Matlab workspace. Okay, remember that workspace is the place to save the data. So import is basically from this to workspace, and export is basically Matlab to this. Okay. For the .mat, okay, in the Matlab format, okay, you can use this coding, load or save. Okay. And you can save it according to the text format or binary format. Okay. The text format is basically the ASCII, and the binary format is not ASCII. Okay. So binary format cannot be viewed in the text editor. Okay. But text format, you can view it inside the text editor, like what you call Notepad. Okay. So that is the difference. So basically, if you want to save in the Matlab format, okay, Matlab format, okay, you have to use the load or save code. Okay, and you can save it in the two format, either text format or binary format. Okay, let us see what is the difference. So for example, you have A and B. Okay, you have A and B. So you want to save all this, so you use the function save. So save, so you have to name the data. Okay, you can name anything, data 1, data 2, ABC, as long as it is not start with number. Okay. For Matlab, don't start naming your file with number. If not, it will be error. Make sure you have to put the ABC first. Any characteristic before the number. Okay. And this is the file name, and of course you have to put .mat. Basically, any data saved by the Matlab format, you will call .mat. This one. Okay. So basically, this one is a default. Okay. Default means that it will automatically save as the binary. Okay, this one. This is the binary. Okay. Binary means, okay, what is the difference between binary and ASCII or the text file? Okay. So the mat file or default or mat file, it will save the variable. Okay, this is the variable as well as the value. Okay, that is for mat. But for the text file, text format or ASCII, it will not save ABC. It will not save AB. It only save the value. Okay. And for this case, For example, if you want to save only a value, okay, you can put it after the naming of the file. So for example, if you have A, B, C, D, E, F, G, you want to save AB. So you just write AB, A space B. Okay. So that is how to save the data. Okay. So this one, when you close your Matlab, it will not lose. Okay. I think this one already mentioned before. Okay. So you have A, you have B. Okay. You save the data. Okay. Data 1, data 2. Okay. This one is basically the same. Okay. Because by default, it automatically saves as this one. Okay. And if you, after that, you clear it. If you want to clear this, you use clear code. Okay. It will delete everything. No, sorry. Okay. It will delete all this inside the workspace if you use clear. Okay, and then if you want to call back, of course, instead of save, you use load. Okay, load data. So automatically this value will be loaded back into the workspace. Okay, so if you load it, you can run the whos. Automatically it will show the characteristic of the A and B. So basically you have value because you use mat or binary file. So both is the same. So it will save the name of the variable as well as the data. Okay, how about the ASCII? Okay, for this one, remember that I said it will not save the name of the data. So if you save this type, okay, if you run the whos back, okay, you load back the data and you run the whos. So basically, it's only called data, which this one. Okay, why is data 2? Should be data 1. Okay. Oh, okay. So the naming should be follow. I don't know why this one is different. Okay, basically, you can see here, all of this is combined together. Okay, A, B is combined together. There is no more A, there is no more B. Okay, it's just one data combining together. So that is the difference between ASCII and MAT. Okay, this one, okay, see, the imported variable name is the file name itself. So if you have the data name is data1, should be, the name will be data1. Okay. Okay. So this is another example how to call. Okay. Create and call. Save and call the Greek letter conversion table. Okay, I don't know whether I want to show this or not because it is quite difficult and I'm not sure whether you can understand it or not. Okay, so basically, okay, it will save, okay, you have a table here, Greek letter table, you have a alpha, beta, gamma, delta, you save a data in terms of characteristic, okay. Okay, this one is basically continuity, okay. If you press enter, it will be new line, okay. If you look at the data in the workspace, it will produce a new line. But if you put triple dot, it will continue, okay. Maybe I show you, okay, this one. Okay, if I run this, you can see that all is 1, okay. So that is mean by triple dot. Even though you create a new line, it will not create a new line. Okay, for example, I remove this. If I run this, it will be error because this one is 1, 2, 3, 4, 5. So for example, I put here, okay, space. So you can see it will create a new line. 1, 2, 3, 4. After you enter, it will create a new line. But if you put dot, 3 dot, okay, you run it, it will continue. Okay. Make sure you know the difference. Okay, of course, this one, if you run this, n is equal to the length of GT. It's basically, okay, for example, here this table is 8 long. Okay, you can see it has 8 data. So what it means by length is just record the length of the data. Okay, you see here this is 8. The length is 8 cell. So it will record the 8 cell and then start hexadecimal. Okay. Okay, if you look at the table back, where is the table 3B1? Okay, if you look at the table here, okay, alpha start with 3B1. Okay, alpha, beta, gamma, delta, this one until here. So you list down there. Okay, you list down all of this. Okay, and then you have B1, B2, B3, B4, B5, B6, B7, B8. So what that mean? Okay, what is this mean is that, so this one. So it start with the 3B1 for alpha, and then you want to assign beta is 3B2, 3B3, 3B4, 3B5, 3B6, 3B7, 3B8. So what this is the function on that. So basically n is equal to 1 until number of table here means that all of this you run one by one, and then the decimal value is just this one converted value from hexadecimal to decimal is 3B1 is equals to 945. Okay, just convert hexadecimal to decimal. Okay, the number to decimal. So you create a table. Okay, let me run this, easier for you to see. If I run this, automatically it create a GL table. Okay, alpha for this, beta for this. Okay, so what's basically it represent the hexadecimal as well as this one. Okay, so and then you save it. So you save the table. So after you save the table, for example, if you want to create a function GL hex equals to this one. Okay, this one is the name, this one is the output. Okay, so this is the code basically. So basically you create a function that load back the table you created before. This one is the table you load back. Okay, and then you compare with the table with the input here. Okay, for example, here you have input beta. Okay, you check one by one with the table. Okay, the first row. Okay, and compare it. And if it's the same, you call back the row 2, which is the hexadecimal number. Okay, that's it on how to implement load and save. Okay, the function of load and save. Okay, we move on to the next part. Okay, other file format. Okay, remember that I said you can save it as file, JPEG, okay, the picture or MP4 or Excel. So for these courses, I only show you one, which is the Excel. Okay, this one I said before, audio, image, you can save it many format. Okay, and first one I show you how to save using Matlab. Okay, Matlab format. Now you can see it in other types. Okay, you can check it yourself for other type, but for this class only, focus at the Excel or spreadsheet. Okay, the code is simple. You just write this one. Okay, to call this one is to save. Okay, okay, how to save is just XLS. Okay, this one is basically the format for the Excel. XLS is the format for the Excel. Read. So you have file name. Okay, of course you have to put the open and close bracket in the file name, and then don't forget the extension. this one sheet. Okay, if you have multiple sheet, okay, if the Excel, okay, I show you Excel. Okay, at the bottom here, you can see at the bottom of the screen, you can see that there is a sheet number. So sheet 1, sheet 2, sheet 3. Okay, if you want to call the number is from sheet 1, you put 1. Okay, from sheet 2, okay, you write range, the sheet is number 2. Okay, next, you know that this is, okay, so file name complete, sheet already complete, XL range. So range, of course, you have to put something like this. Okay, for range, remember, for Excel, for example, you want to take this range. So what it means that if I go equals to, it will go something like this. It is a rectangular from A1 until D2. Okay, or for A1 until D3. For example, something like that. Start Excel until the end Excel. Okay, that is how you load the data. Okay, how about export? Okay, you also can export or write into the Excel. So of course, XLS, write file name, the same thing. The variable you want to save, okay, and then the sheet number and the XL range. Okay, of course, the range where you want to write the number. Okay, okay, I give you example here. Okay, for this example, I don't have the data, so okay, I have to create the data. Okay, where is it? I close this first. Okay, where is it? I create a new Excel and make sure the Excel is the same place as this one. Okay, remember the address. Okay, for example, here I put my file, all of it in the desktop. So make sure you run the file. Okay, you save the data inside the desktop. So this one is time 8:00 AM. Okay. So degree Celsius. Okay. 23, 20, 24, 25, 25, 26, 27. Okay, you have something like this. So you want to convert into Fahrenheit. Okay, first you have to save at the location, the same location as the address of the Matlab. So I call this AAAA. Okay. So if you look here, this is the Excel file at the site, the current folder. This is the address. So I want to, basically I want to convert this one into Fahrenheit. So basically I want to load this data and then write into this. You have two things to do. So how to do this? Of course, this one. I copy back the code. Okay, so temperature in C. So XLS read the number, the name of the file. So remember that I save the file inside the AAAA. Okay. Then if you don't want to mention the what you call the sheet, because this is only have one sheet, so you can ignore it. Just leave the sheet number alone, but you have to mention the location of the data. So you can see here the data in the Excel is from B2, okay, until F2. So B2 until F2. Okay, and how to convert to Kelvin? You just basically add 271.15, and then after complete, you want to print it. Okay, of course you have to refer back the print FPS, and also you want to write it back inside the Excel. So of course the name of the file is changes because my file is AAAA. Okay, what is the variable you want to print? Of course, temperature K. Okay, and then this one, where do you want to save it? Of course, you want to save it at C2 until F3. Sorry, C3 until F3. So basically, if you want here, you want to save here B3 until F3. So this one is B. And of course, this one you have to close first. Okay, if you don't close the file, you cannot run it. Okay, close this. Close the Excel file, and then you run this. Okay, so we will print this. Okay, you will print this, and if you open back the Excel file, okay, if I open back the Excel file, it automatically write inside this. Okay, this is not Fahrenheit. This one is the Kelvin, right? Okay, so that's it. So you have the how to read the data and then how to save the data. So basically, you will save the data inside the Excel. Okay. Okay. This one, I don't recommend you understand it because it's very complicated. So if you remember last semester, you learned about the mesh analysis. So basically how to code the mesh analysis inside the Matlab. Okay. You can try to understand it, but it will take a long time to understand. Okay. You can try to understand it yourself. Okay. So basically it will cover all your knowledge on if else, metric division, okay, logical. Okay, basically this one is the mesh analysis. Okay. So this code is basically mesh analysis. Okay. So you can do this.
Salam, Doctor.
Yes.
Will you have the same type of question on the final exam or no?
The final exam.
Yes, Doctor.
I'm not sure
Circuit
whether
analysis.
something like this is quite difficult to understand. I think not, because usually the question will be much more lower level. This is quite high level because you have to understand a lot of things here.
Okay, Doctor, understood.
Okay, so I cannot promise you, but before if I get the final exam, I will try to analyze whether the question is easy or not, and I will help you to understand if the question is quite difficult. Okay.
Okay, thank you. Thank you.
Okay, welcome. So if you want to understand this, you can. Okay, basically you have to refer back to your knowledge in the mesh analysis, and then after that you can understand this. Okay, if I teach you this one, I think it will take 1 week just to understand this code because it will involve a very confusing concept. Okay, but if you want to learn, you can learn it. Okay. Okay, we go on to the last part, which is debugging. Okay, I think I already show you some of the debugging method, how to debug the code. Okay, so how to debug your code? Okay, usually, okay, the first way to detect the error is basically you look at here. You can see here there is a error, right? The what you call the jiggly line. Okay, the red jiggly line. Okay, this one will show the error. And if you go to the location, you move your cursor there, it will show what is the problem with the script and how to fix it sometimes. Okay, so that is one way to detect the error. Okay, another way to detect error is this location. You can see here there are red. Okay, so basically it will show you where is the location. Red is the error. Yellow has some it's not error, but it's not very good something. Okay, it will run also run, but it's not very good. Okay, so you have to look at the side to see what is the location of the error. Okay, another way, okay, to do the to detect the error is using the breakpoint. Okay, when you run the coding, if the coding is too complicated, you can use a breakpoint. So how to do a breakpoint? So basically you just press this. Okay, automatically it will stop. Okay, basically breakpoint is just to stop the code. Okay, how? Okay, for example here, I put a breakpoint at line 4. Okay, if I run this, it will stop at line 4. See here? Okay, it will stop at line 4. You will stop the stop but the running current line will be shown with the green arrow. Okay, this one. Okay, so basically it will still not run this. Okay, it will stop before it goes to line 4. So you can see here temperature C already run. Temperature K is still not run. So either you can continue. For example, you have the next line is at line 7. If you want to go to line 5 first, you can press step. At the top here, you have step. So basically, it will run step by step. But if you want to continue until the next breakpoint, you press continue. Okay. So for example, I press step first. Okay, it will run the K here. Okay, and if I run continue, it will run until the next breakpoint. So this is how to check your coding, whether it is error or not. Okay. So for example here, okay. Oh, I forget to close the Excel. It will show error. Okay. Okay. For example, I change this. Okay. I'm not sure how to show you error. This code is quite simple. Okay, maybe this code. Yeah, so can. So this one I don't have any example to show you. Okay, this one. So for this one, I think I already show you many times. If there you have a red line under here, that means that this one is the error. Okay, and you have also this one. I also don't have any example for you, but you can see the error location here. Okay, at the side. This one. Okay, this is the breakpoint. Okay, so that's it. That's it for chapter 6. So today you learn about the. Okay, you can see that you learn about the user input, the input coding, which is quite simple. You have a number type and a characteristic type. So you have to put this one, okay, comma, this one. So you learn about the input, and then you learn about the function of the display. It's basically just to show the value without the variable. Okay, or you can show the prompt. And then how to use fprintf and sprintf is basically the same. Okay, but for sprintf you can load the data back. Okay, this one you cannot load the data, you cannot save the data. This one you can, but the coding is the same. Okay, the percentage of f, percentage of e. Okay, and then I show you how to save the and load function. Okay, you can choose two types of format, either ASCII or binary. And then I show you how to read and write inside the Excel. And also show you how to debug. Okay, so today you learn about 6 things. Okay, input, output, debugging, and also input output inside the Matlab itself and input output outside the Matlab. Okay, so I think today we just end our class early. Okay, you have any question before I end the class?
Yes, Doctor, sorry. I think
Yeah?
I missed the QR code scanning.
Okay, where is it? Wait,